Hi, my name is Katie Root from Period 1. I will be doing the energy model problem number 24, cart on ramp. This is the energy model toolkit. The first step is to draw a picture. The second step is to draw bar graphs and define the system. The third step is to make an energy statement and include the word conservation. The fourth step is to write an energy equation. And the fifth step is to solve for the unknowns. This is my problem. The 1.4 kilogram cart is released from rest at a height of 3.3 meters. It coasts down the track. The red section of the track is 0.8 meters long. In this red section, the cart experiences a resistive frictional force. The other sections of this track are frictionless. The height of the smaller loop is 0.4 meters. My first question is, what is the gravitational potential energy of the cart at the top of the 3.3 meter high loop? The solution to this is using the energy equation Ug equals mgh. Ug equals the potential energy, m equals the mass, g equals gravitational energy, and h equals the height. So m equals 1.4 kilograms, g equals 9.8 meters per second squared, and h equals 3.3 meters, as you can see in the question above. So we fill this in with Ug equals 1.4 times 9.8 times 3.3, and the grand total is 45.276 joules. The next question is, what is the gravitational potential energy of the cart when it gets to the top of the 0.4 meter high loop? The solution to this is the same equation, Ug equals mgh. M is the same, G is the same, and H is changed because it's at the 0.4 meter high loop. So then you get Ug equals 1.4 times 9.8 times 0.4, and you get a total of 5.88 joules. The next question was, at the top of the 0.4 meter high loop, the cart is moving 6.2092 meters per second. What is its kinetic energy of the cart when it gets to the top of the 0.4 meter loop? For this equation, you use the kinetic energy, K equals 1/2 mv squared. V is given, and so it's 6.092. M is 1.4, and then you plug it into the equation. So it's 1/2 times 1.4 times 6.092 squared. This gives you a total of 26.99 joules. The last question was, what is the magnitude of the work done by the system as a result of the resistive frictional force? The solution to this includes the energy model. So in my steps, number 1, you can see the diagram above. Number 2 is to draw a picture, and here you can see in the very beginning of the energy model you have potential energy, and then at the very end you have kinetic energy and also potential energy. Step number 3 is making an energy statement. Energy is not conserved because work is done by the system. Number 4 is writing an equation. So we have Ug equals K plus Ug plus work. So you fill this in with variables and you get 1.4 times 9.8 times 3.3 equals 0.5 times 1.4 times 6.2092 squared plus 1.4 times 9.8 times 0.4 plus work, because we have to solve for the work. So overall work equals 12.8 joules.